FastMCP 3 employs a declarative UI composition model where Pydantic-based data validation integrates seamlessly with reactive component rendering, enabling structured form handling through model-driven schema generation. This artifact demonstrates how a BugReport model defines both the data contract and the form interface, with the framework automatically mapping field types to appropriate input controls and validation rules. We're about to examine how the ReportBug tool initializes a form view from the BugReport model, while the CreateBugReport tool processes the submitted data, showcasing the bidirectional flow between UI components and backend validation logic. From typing import literal. From Pydantic import base model, field. From prefab UI, components import column, heading, form. From prefab UI, actions, MCP import call tool. From prefab UI, app import prefab app. From FastMCP, import FastMCP. MCP equals FastMCP, bug tracker. Class BugReport base model. Title, SDR equals field title bug title. Severity, literal, low, medium. High, critical equals field. Title equals severity, default equals medium. Description, SDR equals field title description. Steps to reproduce, SDR equals field title steps to reproduce. At MCP, toolapp equals true. Def report bug, prefab app. Show a bug report form. With column gap equals 4, CSS class equals P6 as view. Heading report a bug. Form from model bug report. On submit equals call tool, create bug report. Return prefab app view equals view. At MCP, tool. Def create bug report data, dict SDR. Create a bug report from the form submission. Report equals bug report *** data. Hash save to database. Return F created bug report, report title. This code demonstrates a clean separation of concerns for form handling in FastMCP 3, using Pydantic models to define structured data schemas. The pattern leverages two distinct tools, one for rendering the UI form and another for processing submissions. This separation allows the form definition to remain declarative while keeping business logic isolated. The BugReport Pydantic model serves as the single source of truth for form structure, validation rules, and field metadata. By using form from model, the UI automatically generates appropriate input components text fields for strings. Select dropdown for the literal severity enum with proper labels and validation. This approach reduces boilerplate while maintaining type safety. The architecture follows FastMCP's tool-based pattern, where ReportBug handles UI rendering and CreateBugReport processes the submission. The call tool action bridges these components, passing form data to the backend tool. This design enables both UI interactions and direct LLM tool calls to share the same backend logic, maintaining consistency across interfaces. The pattern trades some flexibility in custom form layouts for significant gains in maintainability and type safety. Let's break it down. From typing import literal. Imports the literal type from Python's typing module, which enables specifying that a variable or parameter can only take specific literal values rather than any value of a general type. From Pydantic import base model, field. Imports base model and field from the Pydantic library, providing base functionality for creating data models with type validation and field customization. From prefab UI, components import column, heading, form. Imports UI component classes from the prefab UI, components module, column for vertical layout organization, heading for section titles, and form for user input collection. From prefab UI, actions, MCP import call tool. imports the CallTool class from the Prefab UI Actions MCP module, which provides functionality for invoking tools within the Model Context Protocol MCP framework. This class is likely used to create actionable tool calls that can be executed in the MCP environment. From Prefab UI, app import prefab app. Imports the prefab app class from the Prefab UI app module, providing a base application class for building prefabricated UI components in the FastMCP 3 framework. This class serves as the entry point for creating structured UI applications with predefined components and layouts. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol MCP servers. The imported class will be used to create MCP server instances with customizable identifiers. MCP equals FastMCP, bug tracker. Creates an instance of FastMCP with the server identifier bug tracker. The string parameter serves as a label for the server that will appear in MCP protocol handshakes to help clients identify it, but does not control any functional behavior or configuration. The resulting object is assigned to the variable MCP. Class BugReport base model. Declares a class named BugReport that inherits from base model, establishing it as a data model with validation and serialization capabilities provided by the base class. Title, SDR equals field title bug title. Declares a string field named title with a type annotation and assigns it a field descriptor that specifies the human-readable title bug title for this field in the data model. The field descriptor provides metadata that will be used for validation, serialization, and documentation purposes, with the title parameter defining how this field should be labeled in user interfaces or API documentation. Severity, literal, low, medium. High, critical equals field. Title equals severity. Default equals medium. Declares a variable named severity with a type constraint that restricts its value to one of the string literals: low, medium, high, or critical. The field function sets metadata for this variable, specifying a human-readable title of severity and a default value of medium if no explicit value is provided. Description, SDR equals field title description. Declares a string field named description with a title metadata attribute set to description. The field function from Pydantic is used to provide additional schema information, where the title parameter specifies a human-readable name for this field that would appear in generated documentation or UI forms. This creates a typed class attribute that will be validated as a string during object instantiation. Steps to reproduce. SDR equals field title steps to reproduce. Declares a string field named steps to reproduce with a title metadata attribute set to steps to reproduce. The field class is used to define schema properties, and this line specifies that the field should have a human-readable title for documentation or UI purposes. At MCP, toolapp equals true. Def report bug, prefab app. Show a bug report form. Defines a tool function named report bug that returns a prefab app instance, decorated with @MCP toolapp equals true to register it as an application tool in the MCP framework. The docstring indicates this tool displays a bug report form. With column gap equals 4, CSS class equals P6 as view. Creates a column layout container with a 4-unit gap and applies the CSS class P6 for padding, assigning it to the variable view
using a context manager. The column class here is being used as a layout component that will contain other UI elements within this view.
Heading report a bug.
Creates a heading with the text, "Report a bug," in the user interface. This is a UI element that displays a section title for bug reporting functionality.
Form from model bug report. On submit equals call tool, create bug report.
Creates a form instance from the BugReport model with an onSubmit handler that calls the createBugReport tool when the form is submitted. The form from model method generates a form structure based on the model's fields, and the call tool wrapper specifies the action to execute upon submission.
Return prefab app view equals view.
Returns a new prefab app instance initialized with the provided view parameter. The view argument is passed to the prefab app constructor, establishing the view component for this application instance. This line creates and returns the configured application object ready for use.
At MCP, tool. Def create bug report data. Dict SDR. Create a bug report from the form submission.
Defines a function named createBugReport that accepts a dictionary parameter data and returns a string. The @MCP tool decorator registers this function as a tool within the FastMCP framework, automatically using the function name as the tool name and the docstring as its description. The function's purpose is to create a bug report from form submission data as indicated by the docstring.
Report equals bug report *** data.
Creates a bug report instance by unpacking the contents of the data dictionary into keyword arguments. The double asterisk operator unpacks the dictionary keys and values as named parameters to the bug report constructor. This initializes a new bug report object with all attributes defined in the data dictionary.
Return F created bug report. Report title.
Returns a formatted string containing the text created bug report, followed by the title of the report object. This is a simple string interpolation that creates a confirmation message with the bug report's title embedded in it. FastMCP3's declarative UI composition shines here through the tight integration of Pydantic models with reactive form rendering. The bug report model isn't just a data contract. It's the single source of truth for both validation and UI structure. By using form from model, the framework automatically maps field types to appropriate controls text inputs for strings, drop down for the severity enum, while preserving all validation rules and metadata. This eliminates boilerplate while maintaining type safety. The architecture cleanly separates concerns. Report bug handles UI rendering through prefab app, while createBugReport processes submissions. The call tool action bridges these components, enabling both UI interactions and direct tool calls to share the same backend logic. This design trades some custom layout flexibility for significant gains in maintainability and consistency across interfaces. The pattern demonstrates how FastMCP's tool-based approach unifies UI and API interactions under a single model-driven schema.
The decorator weaves a schema net. Yet, the bug report dances through the type system's gaping holes.